It's harvest season on the banks of the Nile, sometime around 1400 BCE, and a field of flax is being pulled out of the ground by hand. Not cut, pulled. Whole stalks, roots and all, because the people doing this work have already figured out something that will take European weavers another 3,000 years to fully appreciate. If you cut flax, you waste half the fiber. So you pull it, every stalk by hand in the sun. That plant, thin as a blade of grass, pale gold and about a meter tall, is going to become clothing so fine that a shirt can be folded down small enough to pass through a signet ring. It's also going to become the wrapping on a pharaoh's mummified body 2,000 years later. It's going to be used as currency, as a burial shroud, as a ship's sail, and as one of the most sophisticated pieces of climate control technology the ancient world ever produced. And almost nobody watching a documentary about Egypt ever stops to ask the obvious question: why linen? Why did an entire civilization, for 3,000 uninterrupted years, standardize on one specific plant fiber in one of the hottest, driest places on the planet, and never seriously switch to anything else? The answer is that it wasn't a fashion choice. It was survival engineering. And once you understand what's actually happening at the fiber level, you start to realize the Egyptians weren't dressing for the heat. They were building a wearable machine to fight it. So today, we're going through the whole story. The plant, the brutal process of turning it into thread, the physics of why it actually works, the class system woven directly into the weave count, and the afterlife of linen, literally. Because this fabric didn't stop working when you died. Quick reminder of what we're up against, because the fabric doesn't make sense without it. Thebes, Memphis, the whole Nile Valley, regularly hits over 40 degrees Celsius in summer. That's above 104 Fahrenheit. There's no meaningful humidity to speak of most of the year, which sounds like a mercy until you realize what it actually means. Your sweat evaporates so fast you can be losing serious water and barely notice you're wet. Your one and only cooling system, evaporative sweating, is running constantly, and every layer of fabric between your skin and the air is either helping that system or getting in its way. That's the entire design brief. Whatever you put on your body has to let heat escape, let sweat evaporate, and ideally block the sun from cooking you directly, all at the same time. Most fabrics fail at least one of those jobs. Linen, almost by accident, nails all three. And to understand how, we have to start with the plant itself, because the fiber's properties aren't a stylistic choice. They're baked into the biology. Flax, the plant linen comes from, is not obviously suited to Egypt. It's a temperate climate crop. It likes cool, damp growing conditions, the kind of weather you'd associate with northern Europe, not the Sahara's eastern edge. And yet Egypt grew it at civilization scale, continuously, for millennia, and the reason is the one geographic fact that explains almost everything about ancient Egypt: the Nile flood. Every year the river rose, submerged the fields, and deposited a fresh layer of black silt across the valley. That flood cycle created a narrow, temporary microclimate, cool, saturated soil right in the middle of a desert, for exactly long enough to grow a temperate crop that had no business growing there at all. Flax was sown right after the floodwaters receded, in soil that was essentially a giant reservoir of moisture the desert air hadn't gotten to yet. It grew fast, it grew tall, and it was ready for harvest roughly 3 to 4 months later, time to beat the return of the heat. Harvest technique mattered enormously, and this is where it gets interesting. Flax grown for fine linen was pulled while still slightly green, before the stalk fully matured, because younger fiber is finer, softer, and more flexible. Flax left to fully ripen and go to seed produced coarser fiber, better suited to rope, sailcloth, and the heavy-duty linen that ordinary laborers wore. Two harvest windows, two entirely different products, off the same field. The Egyptians were already running a quality-tiered production system before they'd even gotten the plant out of the ground. Here's what almost nobody appreciates about ancient linen. Turning a flax stalk into wearable thread is an absurd amount of work, and every step of it happens by hand. First, retting. The stalks are soaked, usually in shallow pools or slow-moving water, and left to partially rot. That's not a mistake, that's the process. Retting breaks down the pectin that glues the useful fiber to the woody core of the stalk, and you have to time it precisely. Under-ret it, and the fiber won't separate. Over-ret it, and you've destroyed the fiber you were trying to save. There was no thermometer, no timer, no lab test. There was someone who had done this every year of their life and knew, by smell and by feel, exactly when to pull the stalks out. Then the stalks are dried and beaten, a process called scutching, to crack the woody core away from the fiber bundles inside. Then comes hackling, dragging the fiber through a bed of sharp pins or spikes to comb out the short, tangled bits and align the long fibers in one direction, like brushing out a knot of hair. Except the hair is a crop that feeds and clothes an entire kingdom. Only after all of that do you get to spinning, and Egyptian spinning was done almost entirely by hand, using a drop spindle, twisting the fiber into thread by rolling it against the thigh or between the fingers. Tomb paintings show rows of women doing exactly this, and the skill required to spin thread fine, and even enough for royal linen, took years to develop. Then it had to be woven on a horizontal ground loom by weavers working in teams, threading and beating each row by hand. Add it up: pulling, retting, drying, scutching, hackling, spinning, weaving. Every single stage done manually by specialists who trained for it. That's why linen quality tracked social status so precisely. Fine linen wasn't a luxury tax invented to look impressive. It was, quite literally, an accumulation of skilled human hours, and the finest linen represented hundreds of hours of expert labor before a single thread touched a loom. Now the part that actually explains the survival story. Flax fiber has a structure that happens to be close to perfect for a hot, dry climate, and none of it was understood scientifically at the time. It was arrived at the way most ancient technology was arrived at, by noticing what worked and repeating it for 3,000 years. Flax fibers are hollow, or more precisely, they have a central channel called a lumen running down their length. That hollow structure means air can move through the fiber itself, not just around it. Combine that with a relatively open, plain weave, and you get a fabric that is dramatically more breathable than something like wool, where the fiber is a solid, crimped structure built specifically to trap air and hold heat against an animal's body in the cold. Then there's wicking. Flax fiber is highly absorbent, and it pulls moisture along its length efficiently, meaning sweat doesn't just sit on your skin under the fabric. It gets drawn up and spread across a much wider surface area of cloth, where it can evaporate far faster than a small, saturated patch of fabric ever could. That's the exact mechanism modern sportswear brands market as moisture-wicking technology, usually built from synthetic polyester blends, as though it were a recent invention. Egyptian weavers were producing the same functional result off a wild grass 4,000 years before that phrase existed. And critically, linen is a poor thermal insulator. Cotton fiber is more twisted and irregular, which traps air, which traps heat close to the body. Wool is built to insulate. That's its entire evolutionary purpose on the sheep it came from. Linen does neither. It doesn't hold heat against you, and it doesn't hold moisture against you. In a climate where your body is desperately trying to lose both, wearing linen is close to the ideal outcome available anywhere on the natural fiber spectrum. And the Egyptians didn't need a material science degree to find it. They just noticed, over centuries, that people in linen suffered less, and they kept doing what worked. There's also the counterintuitive move we have to address directly. Covering up in loose linen kept people cooler than going without it. Bare skin absorbs direct solar radiation and starts cooking immediately. A layer of loose, light-colored linen creates a shaded air gap against the skin, blocks a meaningful share of that radiation, and still lets sweat evaporate through the weave. You lose a little airflow, you gain a lot of shade. That single principle, cover the skin but keep it breathable, shows up independently across nearly every desert civilization on Earth, from North Africa to Arabia. And Egypt was one of the earliest and most systematic versions of it. Not all linen was equal, and the gap between the best and the worst tells you almost everything about how Egyptian society actually worked. At the coarse end, field laborers and craftsmen wore thick, loosely woven linen, sometimes just a simple wraparound kilt, sometimes very little at all while doing heavy outdoor work. Functional, breathable, cheap to produce, and made for people who had no time to fuss over appearance while hauling stone or working a field under the sun. At the elite end sat something called royal linen, or in some translations, linen of 100 threads, referring to an extraordinarily high thread count, achieved entirely by hand on a horizontal loom, with no mechanical assistance whatsoever. Surviving fragments from royal and priestly contexts are so finely woven they are close to transparent, and depictions of elite Egyptians in tomb art frequently show garments rendered as sheer, pleated drapery, precisely because that's what the real fabric looked like. Producing linen at that thread count required flax pulled at exactly the right immaturity, fiber processed with extraordinary care, and spinners capable of producing thread fine enough that dozens of individual strands might occupy the space a single coarse thread would take. Same plant, same climate, same basic technology, and an experience of daily comfort that varied enormously depending on which end of that spectrum you were born into. A wealthy Egyptian in fine, sheer, pleated linen and a laborer in a coarse kilt were both, in principle, wearing the same fabric, solving the same problem. They were not having the same summer. Priests occupied an unusual position in this system, worth pausing on. Egyptian religious law required priests to wear linen exclusively, and specifically forbade wool inside temple precincts, on the grounds that wool came from an animal and was considered ritually impure. Whatever the theological reasoning, the practical result was that the group of people spending the most time in enclosed, ceremonial spaces were also, coincidentally, wearing the one fabric best suited to staying cool while doing it. Here's where the story stops being about clothing and becomes something stranger. Linen's job in Egyptian life didn't end when you died. In many ways, it only really got started. Mummification required staggering quantities of linen. A single mummified body could be wrapped in literally hundreds of square meters of cloth. Bandage strips wound layer over layer around the limbs, torso, and head, sometimes with amulets tucked between the layers for religious protection. Wealthier burials used the finest linen available for the innermost wrappings, closest to the body, while coarser, reused linen, sometimes literally cut up household sheets and garments, was often used for the bulk layers beneath the outer shroud. Even the dead inherited the same quality gradient the living lived inside. And this is where the desert climate and the fabric quietly team up one more time. Egypt's extreme aridity is the reason organic material survives there at all instead of rotting into nothing. And linen benefits from that as much as anything else in the archaeological record. Wrapped bodies buried in hot, dry sand or sealed tombs, in a climate with almost no moisture to support decay bacteria, meant that linen wrappings thousands of years old have survived in museum collections today, still recognizably woven cloth. The oldest known woven garment on Earth, a linen dress from the site of Tarkhan dating back roughly 5,000 years, still exists, still has visible pleating at the shoulders. Because the exact climate that made linen necessary for the living is the same climate that preserved the evidence of it for us. Linen wasn't only a technology for surviving the desert. It became, almost as a side effect, the material record of an entire civilization. The twist: this technology never actually left. All right, here's where this turns over. It's easy to file all of this under interesting ancient history and move on. But the actual properties that made linen work in 1400 BCE Thebes are the exact properties the modern performance fabric industry rediscovered and started marketing as innovation. Breathability, moisture wicking, natural antibacterial resistance from flax's fiber structure, and a poor thermal insulation profile that keeps you cooler rather than warmer. Every one of those is now a bullet point on the label of a $50 synthetic running shirt. Linen clothing is also having a genuine resurgence in hot climate fashion and high-end menswear specifically, because designers rediscovered, or more accurately remembered, that it does the job better than most synthetics that replaced it. We didn't improve on the ancient Egyptian solution to hot weather clothing so much as we spent a century replacing it with petroleum-based alternatives, and are now slowly finding our way back. The Egyptians never wrote a material science paper explaining fiber lumens or moisture wicking. They didn't need to. They had 3,000 years, a plant that happened to grow in the flood cycle, and a habit of paying close attention to what actually kept people alive and comfortable, and then simply not stopping. Go back to that flax field on the riverbank, being pulled by hand in the heat. Nobody working that field understood the hollow structure of a flax fiber, or the physics of evaporative cooling, or thermal insulation coefficients. They just knew that linen worked, that their parents wore it, and that their children would too. And that was enough to carry a piece of climate control technology across 3,000 years, without a single equation ever being written down. Same sun, same sweat glands, same 2% margin before your body starts struggling. The Egyptians solved the clothing half of that equation so thoroughly that the fabric barely changed for millennia, and the industry that eventually replaced it is now quietly copying its homework. So here's the question: would you trade your synthetic, moisture-wicking gym shirt for a coarse linen kilt and a Nile-side summer? Let me know in the comments. Until then, see you soon. If you liked pulling this thread, that's basically the whole channel. Exhibit A: Everyday Objects takes one ordinary thing and finds the 3,000-year engineering problem hiding underneath it. Subscribe if you want the next object the moment it drops, because there's always a history behind every object.